Now numerical number 1, they say a wire of 3 ohm resistance and 10 centimeter length is stretched to 30 centimeter length. Now in the first case, in case 1, the wire is of 3 ohm resistance, so resistance is 3 ohm and the length of the wire is 10. Now the specific resistance, that is the resistivity, not given, so let the resistivity be taken as rho, and area is not given, so let the area of the wire be taken as A. Now the same wire, now this wire is stretched to 30 centimeter length. Now initially the length was 10 and now the wire is stretched to length of 30 centimeter. Now you can see that there is 3 times the increase in length. So if we are stretching the wire and increasing its length to 3 times, then the wire will get thinner and its area will reduce to 1/3. See, length increases 3 times. At the same time, the wire gets thinner and its area will decrease from A to A by 3. So the length is increasing 3 times, so area is decreasing to 1/3. Now what is there, that we haven't changed the material is same, so resistivity will remain the same, because we know that resistivity depends upon the material. So material is same wire. So if resistivity was taken as rho, in the second case also the resistivity will be rho, and the question says we need to calculate the radius of the second wire. Now in both the cases resistivity is same, so what we will do in both the cases, we will calculate the resistivity and equate it, because resistivity is same. Now let's derive the formula for resistivity. Resistance is equal to rho into L upon A. So if we derive the formula for resistivity, resistivity will be equal to R into A upon L. So what we will do, we will calculate resistivity of in case 1, then we will calculate resistivity in case 2, and according to the question, wire is same, no change in material, so resistivity in both the cases will be same. So let's calculate the resistivity in case 1 using the formula R into area upon length. Resistance is 3, area we have considered as A, and the length is 10. So we have got resistivity in case 1. Now let us calculate resistivity in case 2. R2 into A2 upon L2. R2 is unknown to us. Area we have taken as A by 3. So area is A by 3 upon the length. Length is 30. So upon 30. So we have got resistivity in case 1. We have got resistivity in case 2. According to the question, it's the same wire. So resistivity will remain the same. So we can equate these two. So as material is same, so we can equate the resistivity. So same material, there is no change in the material, so resistivity will remain same. So equating the resistivity, for the first one we got the resistivity 3A upon 10. In case 2, resistivity we got R2 into A upon 90. So from here when you cross multiply, this is 3A into 90 upon 10 into A. So you are getting the resistance the resistance will be 27 ohm. So this will be the resistance in case 2. Now in question number 2, they have shown you a diagram. In the diagram you can see there is a voltmeter across the terminals of the cell. EMF is given 2 volt, internal resistance is given 1 ohm, and the external resistance, this one, is given as 4 ohm. The ammeter here is measuring the current and the voltmeter is measuring the terminal voltage across the cell. Now the question is, what will be the reading of the ammeter and the voltmeter when the key is open? Now in case 1, when key is open, case 1, key is open. Now when the key is open, there will be no current in the circuit. So the reading of ammeter will be 0. So ammeter reading that will be 0 because key is open, that means it's an open circuit, and in open circuit there will be no flow of current. So ammeter reading will be 0. Now when the key is open, that the circuit is open, then remember voltmeter across the terminals of the cell, it always measures the EMF. So here voltmeter reading will be equal to EMF of the cell. So the EMF is given 2 volt. See, it's an open circuit. Key is open circuit. So in open circuit, remember voltmeter across the terminals of the cell always measures EMF. Now case 2. See, in case 2, key is closed. Now if key is closed, that means circuit is closed. So there will be flow of current in the circuit. Now if there will be flow of the current in the circuit, so we have to get the reading of ammeter. So here, how to get the reading of ammeter? We can use the formula current is equal to EMF upon external resistance plus internal resistance. So here you can see EMF is 2 volt, external resistance is 4, and the internal resistance is 1. So that will give you 2 upon 5. So 2 upon 5, that makes it 0.4 ampere. So this will be the reading of ammeter. So ammeter reading is equal to 0.4 ampere. Now in the closed circuit, if there is a voltmeter across the terminals of the cell, then remember that it measures the terminal voltage. Voltmeter across the terminals of the cell in closed circuit, it measures the terminal voltage. So if we have to get the reading of the voltmeter, we need to calculate the terminal voltage. So formula for terminal voltage is I into R. So here current is 0.4 and capital R, that is external one, is 4. So the reading of the voltmeter will be 1.6 volt. So this will be voltmeter reading. So reading of voltmeter will be 1.6 volt. So remember this point. If circuit is open, voltmeter reads EMF, and if circuit is closed, then voltmeter across the terminals of the cell, it reads terminal voltage. Numerical number 3. Now here they have given you a diagram. And in this diagram they have said that the equivalent resistance between A and B is 4 ohm. Now what you can see here, if current enters from point A, you can see there are two paths for the current to flow. So that means we are getting a parallel combination here. This is the first path, this is the second path, and current recombines at point B. So here we are getting two paths. So if we go along the first path, then what will be the equivalent, then what will be the resistance of the first path? So the resistance for the first path will be 4 plus 8, that is 12 ohm. Now if we go along the second path, then what will be the resistance? It will be X plus 5. So we have got resistance of both the path, first path and the second path. Now these two paths are in parallel. So what will be the equivalent for these two paths? So R is equal to R1 into R2 upon R1 plus R2. This is the formula for calculating equivalent resistance of two parallel paths. When there are two parallel paths, you can use this formula. Now here R is the equivalent resistance. So here you can see the equivalent resistance is given 4. Then we have R1 and R2. R1 is 12. R2 is X plus 5. Upon R1 plus R2. R1 is 12. R2 is X plus 5. So this will give you 4 is equal to, open the bracket, 12x plus 60. Here you will be getting 17 plus x. Now cross multiply. So this will give you 68 plus 4x is equal to 12x plus 60. So subtract this one. So 8 subtract this. This will give you 8x. So value for x will be 1. So that means this unknown resistor will be having the value of 1 ohm. Now let's see one more question in this same. In this question they have asked you to calculate the equivalent between A and D. Now we have to calculate equivalent between A and D. So what we will do, we will make current enter from point A and exit from point D. Now here when current is entering at point A, you can see current gets two paths to flow. So that means there are two paths which are in parallel. Now these two paths will combine at point D. So if we consider A to D, this one as the first path, so what will be the resistance on the first path? So the resistance on the first path is of 2 ohm. If this is considered as the second path, so if you go along the second path, then the resistance will be 2 plus 2 plus 2, that will be 6. So resistance along the second path will be of 6 ohm. So we have got resistance of the first path 2 ohm, resistance along the second path 6 ohm. Now these two paths are in parallel because current is being distributed over here. So you can apply the formula for two parallel paths, R1 into R2 upon R1 plus R2. So R1 is 2, R2 is 6, 2 plus 6. So that will give you 12 upon 8. So on simplifying it, you are getting, you reduce it by 4, 3 upon 2. So the resistance will be 1.5 ohm. So the equivalent between A and D will be 1.5 ohm. Now in question number 4, you say a cell of EMF and internal resistance. So we have been given a cell whose EMF is unknown and its internal resistance is also unknown. Now this cell is sending a current of 1 ampere. So the current through the cell, this current is of 1 ampere when it is connected to an external resistance 1.9 ohm. So we have an external resistance of 1.9 ohm. So this will be a simplified diagram for it. This is the current. Now this is the main current, right? So formula for the main current is EMF upon R plus R. So in this formula, let us substitute the values. Current is 1, EMF is unknown, external resistance is 1.9 plus internal resistance is unknown. So if you cross multiply, so you are getting this first equation, see. Now the second part says the same cell, it sends current of 0.5 ampere when connected to an external resistance of 3.9 ohm. Same cell. So you can say EMF is unknown, internal resistance is unknown. Now this time cell is sending current of 0.5 ampere and now it is connected to an external resistance of 3.9 ohm. Again here the main current, that is the current being withdrawn from the cell, is known to us. So its formula will be, so current is of 0.5 ohm, 0.5 ampere, EMF is unknown, external resistance is 3.9 plus small r. Now this 0.5, it can be written as 1 upon 2. So this will make our calculation a little bit easy. Instead of 0.5, we can use 1 upon 2. Now when you cross multiply, you are getting 3.9 plus r is equal to, now this is the second equation you are getting. Now what we can do, we can solve these two equations to get value. Now here EMF is 1.9 plus r, so you can substitute here. In place of EMF twice, and in place of EMF you can substitute 1.9 plus r. Open the bracket. So you will be getting small r, that is internal resistance 0.1 ohm. That's the internal resistance. Now let's substitute this value of internal resistance in equation number 1. And we can get the EMF of the cell. So EMF of the cell will be 2 volt. Now in this diagram, you see they have asked you to calculate the total resistance. Now when we have to calculate the total resistance of the circuit, means you need to calculate the total external and then add internal to it. Now if you see in the external part, A and B, these two are in parallel, and then with them ammeter with resistance of 0.8 is in series. So what we will do, first we will calculate equivalent of A and B. Now formula for equivalent of A and B resistance of A to resistance of B upon RA plus RB. A and B both are in parallel, so we are applying the parallel method formula for two resistors. One is 4.5, the other one is 9 upon 4.5 plus 9. So when you multiply it, you will be getting 9 5 45, carry over 4, 9 4 36, and 4 40.5. In the denominator place you are getting 13.5. So let's simplify it. So this will be 405 upon 135. So let's reduce it by 5. 5 2 is 10. 5 8 1. You can reduce it by 9. 9 3s are 9. 9 is 81. So this will give you 3 ohm. So the equivalent of A and B is 3 ohm. Now A and B, which were in parallel, to them this ammeter of resistance 0.8 is in series. So the total external resistance will be equal to A and B in parallel, it's 3, and this ammeter is in series. So it will be 3.8. Now to this external resistance, if we add the internal resistance, which is 1.2, so we will get the total resistance of the circuit. So the total resistance of the circuit, capital R plus small r, so that is 3.8 plus internal is 1.2, so that will give you 5 ohm. That is the total resistance of the circuit. In the first part they have asked you to calculate the total resistance. Now we need to calculate the reading of ammeter. Now you can see in this diagram, whatever the current is being drawn from the cell, it is being read by the ammeter. So ammeter is reading the main current. And what's the formula for the main current in the circuit? I is equal to EMF upon capital R plus small r. So EMF given to us in the question is 2, capital R plus small r, this it is 5. So main current is 0.4 ampere, and this main current will be read by the ammeter. So you can say the reading of ammeter is 0.4 ampere. Okay. The second part says you have to calculate the potential difference across the terminals of the cell. So potential difference across the terminals of the cell, that means in the question they have asked you to calculate the terminal voltage. That will be I into capital R. I is the main current, 0.4, and capital R is the external resistance, total external resistance. So you can see the total external resistance is 3.8. So if we multiply 3.8 by 0.4, so we are getting 1.52 volt. So that will be the potential difference across the terminals of the cell. Okay, now moving to the fourth part. Now this was the second part, reading of ammeter. Okay, now the fourth part says you have to calculate the current through each resistor A and B. Now see how we will distribute the current between A and B. A and B both are in parallel. So here the main current coming from the cell, it is 0.4 ampere. Now this current 0.4 ampere will be distributed between A and B. So let us suppose that A gets 0. A, suppose we get, say, let's suppose that A gets current as IA and B gets current as IB. Now IA and IB, these two are the combination of the total current 0.4. So we can say the first equation that we are getting over here, current through A plus current through B is equal to the total current, because you can see in the question whatever will be the main current coming from the cell, this main current which we have calculated 0.4, it will be divided between A and B. So let us consider current through A as IA and current through B as IB. So we have got the first equation. Now as A and B, these two are in parallel, so the potential difference across these two will be same. So let us calculate. So we can say potential difference across A is equal to potential difference across B. So this will give you IA into RA, IB into RB. IA into RA, that is the resistance of A, it is 4.5. Now IB, from first equation, this one, you can get IB. IB will be 0.4 minus IA into RB, resistance of B is 9. Now this 4.5 will reduce 9 2 times. Now when you open the bracket by 2, you are getting 0.8 minus twice of IA. So this will become thrice of IA is equal to 0.8. So current through A will be 0.8 upon 3. So that will give you remove the decimal, 8 upon 30, that is 4 upon 15 ampere. So this will be current through A. Now we need to calculate current through B. Now to calculate the current through B, see, now here first equation says IA plus IB is equal to 0.4. So we can solve this equation. IA plus IB is equal to 0.4. IA we have calculated 4 upon 15. The 0.4 can be written as 4 upon 10, that is 2 upon 5. So IB will be equal to LCM will be 15. So current through B will be 2 upon 15. So we have got current through A and current through B. Now in the fifth part, they are asking us to calculate the potential difference across A. Now current through A is known to us. Resistance of A is also known to us, so we can get potential difference across A. So potential difference across A, current into resistance. Current through A, see, current through A we have calculated as 4 upon 15, and resistance of A, it is 4.5. So let's solve this. 4.5 multiplied by 4, this will give you 18 upon 15. So reduce it by 3, 3 6 3 5 6 upon 5, that is 1.2. So this will be the potential difference across A. This is clear to you?